This presentation is my midterm project, seam carving for content-aware image resizing. So this is basically a replication of two papers which give us two strategies for image resizing. The first one is backward energy, which looking for the lowest energy seam. And second, forward energy, which looking for the seam makes the lowest energy future image. This is a backward equation we're following, and the basic idea is for each point, we look at the nearest three neighbors, pick the smallest one, and add the energy at the point itself. Algorithm and seam insertion. I'll say this is the most tricky part of this project because the strategy we're using is we insert seam in the order of removal. So if we use exactly same indexes, it will end up with a left-heavy picture. And if we try to look for the same value of the seam and adjust the indexes, it will end up with unconnected seam. So the strategy I end up with using is I only adjust the last row's index and trace back from there. For forward, it's similar as backward, except we are focusing on the changing part. Here are some results. Statistically, I measured the comparison with both mean squared error and structural similarity, or SSIM, which is a number between -1 and 1, and we want to achieve as close to 1 as possible. And virtually, I calculate the difference and generate a picture and shows which part has the largest difference. This is a backward seam insertion, and I achieved 0.72. And here shows which part is the difference. This is a 2 steps, 50%, and I got 0.7 with an error of 558. Backward seam removal, I got 0.75. This is the closest one I have ever had for this whole project. Forward, I got 0.72. Last one is backward and forward seam insertion. I got retrieved 0.58 and 0.6. Thank you.